So basically, I'm continuing the video. Basically, my solution was there because the video cut off. Basically, you can change the old transcript if you're following this. Basically, if you have Jordan, stop. So basically, if you're doing stop looking at me, go fix this problem. Look, so if you're doing one read, you're doing two writes. So you're doing two writes, two reads, which are interfering with release. For example, so you get a table of 0 1. I mean 1 0 1 0, which equals to 1 1. I get a table 1 1. So you get a total qubit of, so you get 6 bits. 1 0 plus 1 0. Basically binary calculator. Stop, Jordan! Stop! No, don't look at me, Jordan. I'm not your friend. Just stop! I'm working. So it's like annoying me. It's really annoying me to get Ryan 1 1. So binary, basically get, for example, what's saying to you, basically if you do one right, 1 plus 1, or 0 1 plus 0 1 is 1 1, and then that 1 1 plus 0 1 is 1 1 1 1, and you get another 1 1 1 1 plus 0 1, well, that'll be 1 1 1. You get 4 bits, 4 bits are states of 1 or 0, depending on what you're reading or writing. But that's basically two. Basically, when you're using those 2 bits, 1 1 1 1 or 0 0 0, because basically when you read the information, you are actually executing some instruction. So you are literally destroying the opposite information. You're creating something to read something. You are writing to write it. That's what I'm saying. So the goal is this: you have to 4 bytes, 4 bits. You have to store, so make sure there's no fragmentation ecosystem. What that means, Namdi, is when you have 2 set bits, 0 1. I mean 1 0 plus 1 0 plus 1 0 plus 1 0, you get 1 1 1 1. Based on, and you discard the epsilon state of 0. You don't discard the 0 as well because you're still off the gun kick. Basically the 0 is epsilon state, which can be attack vectors that based on quantum system. But it's the epsilon states you can't even measure. So you can measure. But basically your 1 is not 0, so you have to keep the epsilon state or nil. States that, but you have to preserve the memory structure. For example, now you get 1 1 1 1 and 0 0 0 0, and then you do XOR 0 to get your way to store on a computer or run. So you can copy the position. Basically, the solution is this. So basically, your solution to the measure is to develop some kind of memory mosaic system that remembers the colors, color coded for bit information. So you store system. Remember the basically it's mosaic memory, but from quantum architecture. So the memory is like rift bound to the R syntax. So the capital R colon colon formatting colon from regular expression for something you send from Rift to another language such as C, for Rust to C, with some predefined macros. Like if I define if not defined Rift, I have to use if not defined Rift, I get the opposite one. If not defined Rift, include Rift slash H. But I'm using C, so I use the opposite of C. So I use if not defined, then define the macro how to include the Rust the cargo system for Rust and C. So I love the site information. The C right C rank binding. Basically, you have to just try to build it yourself. So if you're in the masking operators, which is opposite flip, basically you have the flipped opposite for the XOR gates you create for every information. So when it's not in a state of a space, which is like a bit or byte that's stored, it's in a state of running, current executing. So when it's not stored, it's being executed, and you can only mix the two because when you do a read, you are in parallel, you're processing 2 states at a time. So when you're reading, you're writing. When you're writing, you're reading. But these states are ahead of time, so you have to ensure that the memory is separated for that architecture. You don't have any information based on the mosaic memory system. So when you read a bit, you destroy it, and when you destroy it, you have destroyed it because when you read something you have destroyed it because you read it because you read it and you didn't have the memory to um to not read it, so you didn't think about what you're gonna do with it. Basically, when you read it, you really executed it. So because you observe the state, when you observe the state, you say it's destroyed, destroyed. But when you observe it, when you go to observe it and keep the memory to perform later. So you have the memory look. So you have the bytes stored. So the system does allows you to write, execute, and do other things without fragmenting the whole memory model. So I'm proposing a mosaic memory system for the rift-bound pipeline stages for quantum architecture. Thank you guys, Namdi. Via Rift Bridge.